Welcome. Today we're going to talk about something really cool. We're moving beyond just querying your data for what it says, and we're going to figure out how to unlock what it actually means. And the best part? We're doing it all right inside Snowflake.
All right, to really get this, let's kick things off with a problem that I'm pretty sure drives all of us a little crazy. The simple and often frustrating limits of a basic keyword search.
Yeah, you know the feeling, right? That nagging sense that the answer is in there somewhere, but you just can't find the exact magic words to pull it up. It's a super common problem.
This example just nails it. A keyword search looks at this and sees zero connection. To the computer, user and client are totally different. Install app and phone setup, worlds apart. It's so literal, so rigid, it completely misses the obvious semantic link, the shared meaning that a human sees instantly.
So, if keyword search is the problem, what's the solution? How do we get a computer to understand context and nuance? Well, the answer is a really powerful concept called Vector Embeddings.
So here's the core idea, and it's kind of brilliant. We're basically translating the fuzzy, complex meaning of human language into the one thing computers are amazing at, math. We're turning abstract ideas into a list of numbers, a vector. And the process itself is actually pretty straightforward. You take your text, you feed it into an AI model, an embedding model, and what you get on the other side is that vector. It's just a long list of numbers that now mathematically represents the essence of that original text.
I absolutely love this analogy. We're creating a map of meaning. On this map, things with similar meanings get placed close to each other, just like cities in the same region. So king and queen would be neighbors. Happy and joyful would be right next to each other. It's this idea of spatial relationships for concepts.
Okay, so that's the big idea. But how do you actually do this? How does Snowflake make this a practical reality for your own data? Well, that's where the Cortex AI Toolkit comes in.
Right out of the box, Snowflake gives you a whole suite of these embedding models to choose from. You've got options for just English or for multilingual text. You can pick different vector sizes or dimensions. Just think of dimensions as how detailed the map coordinates are. More dimensions can capture more nuance, so you just pick the right tool for your specific job.
And this is what makes it so amazing. You don't have to be some machine learning wizard. All of that complexity is wrapped up in a simple SQL function. You just call embed text on your text column, and Snowflake does all the heavy lifting for you, right there in the database.
So once everything has coordinates on our map, we need a ruler, right? A way to measure the distance between points. And that's exactly what these functions are. Cosine similarity is a really popular one for text because it measures the angle between two vectors. It's less about the length of a sentence and more about the direction it's pointing, meaning-wise. It's how the computer knows two different sentences are talking about the same thing.
Okay, theory is great, but let's put this all together and see it in action. We're going to look at two incredibly powerful real-world applications, something called vector similarity search and a technique called retrieval augmented generation, or RAG.
Let's go all the way back to our help desk problem. Now with vector embeddings, we're not searching for keywords anymore. We're searching for meaning. We can take a new support ticket and ask the system, hey, find me everything else in our history that feels like this problem, even if the words are totally different.
And what's just mind-blowing is how simple the query is to do this. We're just telling Snowflake, hey, calculate the cosine similarity for me, and then just show me the top 5 most similar issues. That's it. It's a full-blown semantic search, and it's written in plain old SQL. Now, we can take this a huge step further. We can use this amazing search capability to fix one of the biggest challenges with large language models, preventing them from just making stuff up or hallucinating. This RAG technique basically supercharges an LLM by giving it the exact factual context it needs from your own data to give a good answer.
So here's how that little dance works. A user asks a question. But instead of just blindly sending that question to an LLM, we first do a quick vector search on our own knowledge base to find the most relevant documents. Then, we package up that specific context with the original question and hand it all over to the LLM. The result? A super accurate, context-aware answer that's grounded in your own truth. And check this out. The entire RAG process can be captured in a single SQL statement. The first part finds the best document from our wiki using vector search. The second part then feeds that document directly into Snowflake's complete function to generate the answer. It's a complete, secure AI application, all inside your database. It's incredible.
So let's just zoom out for a second as we wrap up. what does all of this really mean for you and all the data you're sitting on?
Well, the takeaways here are pretty huge. First, you can finally understand the meaning buried in your text data. Second, you can do it with simple SQL functions you probably already know. Third, you can build these really sophisticated AI apps with just a few lines of code. And maybe most importantly, you can do all of this securely within the Snowflake environment you already trust.
Oh, and here's a crucial little detail for anyone thinking about the budget. While yes, there's a cost to create the embeddings in the first place, running those similarity searches to compare them, that has zero token-based cost from Snowflake. This makes running these powerful search apps extremely cost-effective.
So I'll just leave you with this question to think about. Look at all the text data you have, all those customer reviews, support tickets, internal docs. What are the hidden connections, the untapped insights that are just sitting there waiting for you to find them? Not by searching for words, but by searching for meaning.